Hello, California geography students. This is your instructor, Dan Scollin, and as promised, I am going to be doing an Exam 1 review. Remember to bring a Scantron, a pencil, and you may bring exam notes, one page, one side of one 8.5 by 11 page handwritten, or two sides of a half sheet. All right, so we talked about and introduced this idea of trying to make sense of this complexity of California, and I would argue that geography is a great way to approach this. Geography, the spatial science. There are 5 themes of geographic science that can help with this process. We can talk about location. We discussed both latitude and longitude as absolute location and also relative location. Place, the unique characteristics. You did a fine job describing some of the unique places in your different regions. Human environment interactions and movement of weather systems and so forth. And finally, the region, which is a key aspect where we have these uniform characteristics that we'll look at. Example of absolute location for the Shasta campus. Remember, we have this great range of latitude from 32 degrees in the south to 42 degrees in the north. And this exerts a strong influence on culture, or excuse me, on climate. Okay, by contrast, we could talk about relative location, where California is situated in the world, and of course the Pacific Rim is an important characteristic. Related to this is site and situation. You can think of site as being conditions of the place and situation as connections determined by relative location. The idea of scale, as we zoom out and look at California or any place in a global context, a regional context, and then focusing in on the place itself where we get greater and greater detail. Of course, physiographic regions, we spent a lot of time talking about this. You should be familiar with these regions and why they're defined as unique regions. This is not a map quiz as such, but you should be familiar with this map and be able to identify these on a map. Okay, California's dimensions. So one of the things that we can do in describing California is to look at its overall dimensions, and these aren't things that I'm going to look for particular numbers on, but this range of elevation from 14,000 to 200 feet below sea level is a useful bit of information, a 1,200-mile coastline, and of course also a population of 38 million people. Remember, of course, that population is very unevenly distributed. Some of the reasons we'll be getting into more, but some of the reasons we discussed in terms of the concentration in Los Angeles and the Bay, especially around jobs and opportunities afforded by the coast. Again, this was introduced early on in the course and is something that really will be more of the focus of the next part of California's exploring the state beyond the first exam. But remember that we have this very rich and diverse characteristic of not only the natural environment but also of the culture as well. Pacific Ocean, of course, exerts a very important influence on a number of factors of California, including our climate. We get the moderation of temperatures in the coastal regions, but we also get fishing resources, access to trade, recreation, and also hazards. And these are all things that are important, especially considering the high concentration of people in the coastal regions of California. Why is California so mountainous, and what geographic effects do mountains produce? This is a theme we spent quite a bit of time exploring, and of course plate tectonics theory is at the root of understanding why California is so mountainous, existing as we do on the Pacific Ring of Fire, where we have this margin around the Pacific that has a large proportion of the Earth's earthquakes and volcanoes. And just in understanding the process of plate tectonics, we need to keep in mind these three types of plate boundaries or plate margins, each of which is represented in California. A couple of the key processes that occur as we talk about these different boundaries. Of course, the sliding boundary, the transformed boundary that represents the San Andreas Fault. We have vertical block faulting, which produces extensional stress on the Earth's crust, producing the basin and range. These vertical blocks, down-dropped blocks become basins, uplifted blocks become the ranges, including the east side of the Sierra Nevada, even though that's considered a different physiographic region. So some broad sequence in terms of when things occurred, and you're sort of reading from the bottom up, not so concerned about the left side with the actual ages themselves, but rather the sequence. Of course, the rock cycles, the three fundamental types of rock: igneous, sedimentary, and metamorphic. Again, very diverse in terms of their representation in California, and these of course produce valuable mineral resources. Gold, of course, strongly associated with California from the gold rush, but we also have other minerals that have been mined extensively in the Klamath region, in the Basin and Range region, the Peninsular region, and the San Joaquin. And it's important to recognize when we talk about these energy resources that we also remember how some of the impacts that we've seen of these over time, where we're seeing toxic contamination of creeks, acid mine drainage, for example. We're doing fracking now in the San Joaquin Valley, which is contaminating water, groundwater. So lots of consequences associated with this mining history, which is still active to this day, by the way. We still mine quite actively throughout California. Okay, we talked about volcanic activity, different zones of volcanic activity for the state of California. Of course, we're most familiar with the Cascades and the Modoc Plateau, but remember these other regions that are active as well. Again, explored earthquakes, particularly the folding of and faulting that occurs as a result of tectonic stress, most best represented on this slide by this convergence of the Cascadia subduction zone and the San Andreas Fault zone, which occurs at Cape Mendocino. Notice the arrows indicating the relative movement of plates, with the subducting Gorda plate plunging underneath the North American plate, with the Pacific plate sliding past the North American plate in that transform zone. This is the displacement along the San Andreas Fault. Again, you see these signature features on California's landscape resulting from landforms, resulting from the stress along these tectonic faults. If we talk about landforms themselves, this is Shasta Bali as one example. In addition to these tectonic processes, earthquakes and volcanoes and faulting that uplift landforms, we have degradational processes, the weathering of rocks, the erosion of material, and the mass wasting of large volumes of material under the force of gravity, and then the transport of material by water and other forces. Finally, the deposition of these sedimentary materials. A few examples here. Landslide event in Southern California. A lot of concern about this right now with the heavy rains that we're receiving. Okay, the floodplain. So some of these river landforms. One area of landforms that we discussed, the coastal landforms. Again, just recognizing some of these more prominent landforms. Glaciers played a really important role in the state of California, so cirque basins, U-shaped valleys, and so forth, representing the many landforms found in California. Kind of a unique aspect of the desert region, these interior drainages, alluvial fans were the feature that I described. Remember, we had that discussion about Mount Shasta and its vulnerability to landslides and debris flows. Okay, so factors influencing climate, of course, latitude, elevation and topography, and ocean influence. So you want to spend a little time reviewing these for yourself. The role of these unique air masses, the Aleutian Low in the winter, and the East Pacific High in the summer. Mountains, of course, playing a very strong role. You want to be familiar with the role of orographic lifting and the rain shadow effect. So the orographic effect, and that, of course, is prominently represented in the distribution of precipitation in the state. And remember, mountains also play a very important role in terms of temperatures, cooler temperatures at higher elevations, generally speaking, but also their role in blocking the moderating effect of the coastal influence. Okay, so we could look at different climographs that show distribution of precipitation and temperature over the course of the year for a given location, in this case Los Angeles. Okay, some of the climates that are represented, these broad climates. B climates are desert and arid. C climates are mild. In the case of California, Mediterranean climates. Cold, higher elevation climates, also Mediterranean. And finally, the very high elevation tundra climates. A little bit of fundamentals of climate. Not too much on this on the exam, but it's informative to remember this dynamic system that produces our long-range patterns of precipitation and temperature, which is the definition of climate. And of course, we get these anomalies. This is from a few years back, and of course, California naturally has a lot of these drought periods, and all of a sudden now we're hitting into this very heavy rainfall period. And so this is characteristic of California historically, although we are seeing changes with climate change, especially the earlier melt-off of the snowpack, major concern. But remember that we have a history that includes a ice age where much of the high mountains were covered in glaciers, and the resulting glacial landforms that we talked about. The role of atmospheric pollutants is one that is a concern. There are natural pollutants, but of course human industry is a major concern, with carbon dioxide and methane being two of the more prominent ones. As I mentioned earlier, snowpack, longer, drier summers. These are sort of in sequence of their importance, or at least in terms of what we're seeing now. Rising sea levels in the future could be a real problem for California. But some of the broad-ranging impacts, and again, these are starting to emerge, especially the earlier snowpack. So California's leading role in addressing climate change. Biogeography in the last minute that we have here. You have a definition of biogeography, these major patterns of vegetation. Remember your cismontane, montane, and transmontane. You should be able to distinguish those. The role of vertical zonation. This is a sequence. It's good to be familiar with this transition as you increase elevation from the grassland into the blue oak woodland, into the chaparral, up into the lower and upper montane subalpine forests. I'm just going to sequence through some of these major vegetation communities, some of their characteristics. some dominant species associated with them. And we're going to run out of time